Dave here. In today's video, I'm going to be replacing a failed TXV. Normally what I would do in this situation is I would pump the system down, trap the refrigerant in the compressor and condenser coil, recover the rest, and then let loose the refrigerant once the repair is made. However, we found a couple problems on this one. Failed TXV, a refrigerant leak where the TXV was installed, and we have a lot of moisture in the system. So we're going to recover all of the refrigerant out of the system, fix the leak, replace the TXV, and charge the system with brand new virgin refrigerant. Let's get it. Make sure we get all the air out of these lines. While that's recovering, I'm going to go ahead and prep this liquid line dryer outside for replacement. The cleaner you get the copper, the easier it is to braze. We didn't even pull out 3 pounds. The leak down there was pretty bad, and I believe this system was on empty before, which is probably how the moisture got in when they recharged it. So I'm gonna undo this, and what I'm gonna do now is hook this up to my nitrogen tank and my nitrogen regulator, remove my hose from the liquid line, move the valve core from the liquid line. The reason I'm doing this is because I'm going to fill the lines with nitrogen while I'm brazing. Next, I'm going to deburr these lines that I cut. Knock as much as that. Get all those copper shavings out. Our new liquid line dryer, we want pointing towards the evap. I had to make an extension. We're going to purge all air out and excess refrigerant, and then we're going to flow nitrogen on this braze setting so that can displace any oxygen that may form inside the piping. For 3/8, I like to use 5 and 5. I'm going to open my acetylene first. We're already at 5. And I need to turn down my oxygen. That's going to give me the flame I want for 3/8 copper. Want to inspect the bottom of all my joints, make sure I filled in the gaps, and we're looking good. Cap on this for now. Let's head downstairs and swap out that TXV. All right, just gonna break this nut loose first thing. And some nitrogen built up. Not sure why this is insulated up here. It's making it way more harder than this needs to be. And we gotta loosen this nut up here, which is in a very bad spot. There we go. That's our flare fitting. And since the leak was right here, I'm going to cut back right here. And there's another problem. This has a piston in it. There we go. And the O-ring is in there, so we cannot get this too hot. I'm gonna borrow this piece right here. Set that there for now. Got our soaking wet rag. Got that wrapped nice and good. I don't want that making any noise. Now to hook up our flare nut, which you won't be able to see on camera. The correct terminology would be equalizing tube. Got that nice and tight. Don't want to over tighten it. Let's leak check before we hook everything else back up. Which unfortunately means another trip up to the roof. Would be nice to have some help today, but gotta do what you gotta do. And since I'm not down there, I'm only gonna go to 50 and see if anything drops before I add more. 74. Let's make sure it does. Let's wait a couple minutes before I head back down and make sure it holds at 74. And as you can see, we're in the red. That means my tank's almost empty. $197. I'm gonna go ahead and do a pressure test. 196, I'm sorry. Grab our bubbles. Back up at the roof, everything's looking good. We can go ahead and let this nitrogen out and set up our vacuum pump. I'm gonna be vacuuming with two valve core removal tools, this Apion one and this field piece one, so we can stick our micron gauge on this extra port. Valve core is already removed out of this one. Now this open. And we've got a lot of bouncing around so far. But that's expected because I know there was moisture in this system, so it's going to take a little bit longer to get clean and dry. I may even have to do a triple evacuation where I break it with nitrogen once I get down to 500 microns or so and start over with the evacuation. Did go ahead and close down on the gas ballast. We're getting close to being into a deep vacuum. We're below 600 and we're going down about 20 per minute. So right now what I'm gonna do is shut down on this. Shut down on this valve. And then turn the vacuum pump off. And you can see we did jump up to 800 pretty fast. And now I'm just gonna brake vacuum with nitrogen. Leave some of that air out of the hose. And I'm not gonna go too much. One, because I don't have much nitrogen left. Until it comes out of the other side. And I'm just gonna close down on the valve. And then hook up my hose once it's very faint. Close that. So we want to keep as much air out as possible. All right, now we start the vacuum process again. Ballast back to open. We got our bulb on there tight in the 2 o'clock position. Now I'm just gonna put some of this insulation over it. And this is like sticky stuff. 373. I'm gonna go ahead and sweep nitrogen through one more time so we can have a triple evacuation. Back around the same amount where we were, 350 microns. I'm gonna go ahead and do a decay test now. Shut down on both of these valves and then we'll check our rise after 10 minutes. Shut down on that valve. Turn off the vacuum pump. It's been 10 minutes. This is not a good decay test, but technically it does pass. So I'm gonna brake vacuum and get this unit running. Valve that off. And I'll be using different gauges to brake vacuum because these low loss ones can kind of screw with it where you can't get all the air out of the lines because of the low loss fittings, and then you just pump a little bit of air back into the system, which is not what we want. Zero out the scale. And what we're looking for on this one, we're gonna put in 3 pounds, and then we're gonna accommodate for 30 to 50 feet of line set. Gonna crack this open. And I'm just gonna start off with 1 pound and then put the valve cores back in. And the reason I'm doing that is because I don't want to slam this in there. Since there's no valve cores, the valve cores can meter the refrigerant a little bit. Okay, we got 1 pound. Now it's time to put the valve cores back in. Take any more refrigerant. We have to go downstairs and turn the unit on. But I'm gonna start picking up because rain's coming fast. Unit running, it just sucks it right in. Now I can go back to the digital gauges to quickly get that subcool dialed in and make sure that our TXV is working by measuring the superheat. All right, 17 superheat, 8 subcooling, 128 over 320. Now, the readings are still bouncing around a little bit. There's still moisture in there, even though it passed the decay test. But I don't think I'm getting that out without replacing the compressor oil. Unit's 11 years old, so we'll see how many more years we can get out of her. But you can notice from our before readings that our superheat is lower and our suction pressure is higher. So that TXV is trying its best to do its job, which is to regulate that superheat at around 15 to 18 degrees on this model anyway. Thank you so much for watching. My name is Dave, and this fix is done.